is equal to u cube. Why? Because this is 5 by 3 power. If power is r upon s, we substitute here 1 plus root t is equal to u cube. That means if I differentiate it, it will give us differentiating it with respect to u. We will have 1 upon t under root t negative or t to the power minus half. That means 1 upon root t into dt equal to 3u square into du. Okay, so take this 2 to the other side, it will be 6. So 1 upon root t dt is equal to, this is 1 upon root t, okay, dt upon root t is equal to 6 u square du. Directly we can substitute this value here. So okay, let me take this. What do we get here? Let me put it here. So finally we get the answer. Okay, substituting this further, this dt upon under root t is 6 u square in the numerator, 6 u square du. In the denominator, what do we get? 6 u square upon du, and in the denominator we get 6 raised to power, what is that? This value, this is there. So 5 u raised to power 5 power into, sorry, du is there. So finally, what do we get? So we get here, sorry, let me take this. So finally we get u raised to power 5, because if I substitute here u cube whole power 5 by 3 means 3 cancels out, only 5 power is there. This is, and dt upon root t is equal to 6 u square, that we have substituted in the numerator. This is the value into du is there. Okay, so let me write this now. Finally, this value is obtained. Let me solve it now. So what is the final solution of this? Let me check. This is the third type of question we have done. Now this will give us 6. Let me take out. It is u square means 1 upon u cube. That means u raised to minus 3 du. Okay, so this will give us 6 u raised to power minus 3 plus 1 upon minus 3 plus 1 is constant of integration. Okay, and 1 plus the root t we substituted as u cube. That was also substitution. Second substitution. This is the first substitution. And this is second substitution. This one. 1 plus root t is equal to u. Alright. Now first we have to convert u whatever u comes out. Let me write here. This is minus 2 in the denominator. 6 upon minus 2, that means minus 3. Okay, and 1 upon u square, so it will be u minus 2 power. Minus 2 will come in the denominator. This is minus 3 upon, that is minus 3 upon u square. So the value finally is minus 3 upon u square. U square, it will be, okay, 1 plus root t whole power. This is whole square 2 by 3, because u is equal to this whole power 1.3 and u square equal to 2 by 3. It is power is 2 by 3. I'm sorry, this is 2 by 3 here, plus constant of integration. Now if I substitute the value of t, which is 1 upon x, t is equal to 1 upon x, x is equal to 1 upon t, so t is equal to 1 upon x. I substitute here, so it will be 1 upon root x. T is 1 upon x, so it will be 1 upon root x, so it will be 1 plus root x upon root x. That means x raised to power half in the denominator. Its power will be 2 by 3, and this is also 2 by 3. Okay, this will come in the numerator. This value, because this upon this will come in the numerator. We will have minus 3 into x raised to power 2, cancel out 1.3 upon, within bracket, 1 plus root x whole power 2 by 3. This is the answer here, plus constant of integration. Finally, this is the answer. This is what? Minus 3 x raised to power 1.3 power. This will come to cancel out. 1.3 power will left over. This is x to the power 1.3 will come in the numerator here, positive value. Minus 3 x to the power 1.3 divided by 1 plus under root x over 3. So this is answer here. Finally, question number second is of third type. Okay, third type question which we have done. Question number second one is we have done. Now let's talk about next question. Question number third now. What is this kind? This is of first type. That if b is an integer, then how we have to do this? This is question number second. Let me take that. Question number second here. Sorry. Second we have done third one. The third one is okay, whole square. Alright, so this is sign of integration x is equal to 2 by 3. Within bracket, it is 1 plus x is equal to 6 upon 5. Whole power 2 dx. Now here we see that this b is equal to here b is equal to an integer. So opening it again with binomial solve, or this is square, so we can open it easily. So this will give us sign of integration x is equal to 2 by 3. Okay, here integer, so opening it with binomial solve, opening it will be 1 plus x is power 6 to 12, 12.5 plus 2 into x is power 6.5 into dx. Okay, so this is whole square of this. A square plus b square. B square means 6 to 12, 12.5. 2 into a, or we can write in this order. Yes, 1 square plus twice a into b plus b square. B square is reality. In any way we can write it. Okay, so now let me multiply by x is equal to 2 by 3. X is equal to 2 by 3 into 1 means the same value plus sign. Let me write this second sign of integration. This will be written as x raised to power 12.5 plus 2 upon 3. Okay, dx plus 2 into sign of integration x raised to 6 upon 5 plus 1 upon 3 dx. Okay, now this directly integrate. This will be x is equal to 2 upon 3 plus 1 upon 2 upon 3 plus 1 plus, let me first write it as with proper power. This is now 36 and 5 to the 10. 36 plus 10 is 46. 46 upon 15. X is equal to 46 upon 15. Okay, this is the power of this. Why? Because if I take 5, 3 and 15 LCM, 3 into 12, 5 into 2, 10, 3 into 12, 36, 36 plus 12, 36, what am I 12 is 36 plus 10, sorry, 36 plus 10, 46, alright. So it is 46 only. So 46. Okay, so this is the question. Now into dx plus 2 times this is to be added 6, 3 are 18, 6, 3 are 18, 5 plus 10, 28. Actually for 28 upon 15 into dx. Now can be integrated. These two steps can be integrated now easily. What is the answer finally? This is 2 plus 3, 5, 5 upon 3. Actually for 5 by 3. X is for 5 by 3. And this will be 5 upon 3, 3 upon 5. 3 upon 5 into x is for 5 by 3. Plus it will be plus 1. Let me write first. X 46 upon 15 plus 1 upon 46 upon 15 plus 1 plus 2 into x raised to power 28 upon 15 plus 1 upon 28 upon 15 plus 1 plus constant of integration. It will give us 3 upon 5 x raised to power 5 by 3 plus now 15 plus 46 will be 5 plus is 11. Right here. This is 11. So x raised to power 11 means 1 carry, and 5. What I'm adding just 5 plus 6 11 1 carry, and 5 plus 1 4, sorry 4 plus 1 5 plus 1 6, 61. It is 61 upon 15. Okay, and it will be 15 upon 61. 15 upon 61. And the denominator we will have a plus sign. This is 2 into, so this is 8 plus 5 13, 3 x to the power 3. 8 plus 5 13, 3 1 carry, 2 plus 1 3 and 1 4, 43. Yeah, 43 upon 15. 43 upon 15, so it is 15 upon 43 plus constant c. And let me finally write it down. It is 3 into x to the power 5 by 3 upon 5 plus 15 x to the power 61 upon 15 upon 61 plus 2, this one 30. 30 into x to the power 43 upon 15 upon 43 plus constant of integration. This is the final answer of question number 3. Question number 3 is done now. Okay, this is fixed. Question number 3 is fixed now. We solve. Okay, so this is the answer of question number 3. Now let me take next question 4th. Now question number 4th, what does it say? Okay, so question number 4th. Let's talk about what is the question number 4th say. Now question number 4th, let me change it. Okay, question number 4th. Okay, now this is again p is an integer. So 4th question is of integration x raised to the power 113 within bracket it is 1 plus x raised to the power 3 by 4 whole power 3. This is q. Okay, so this will give us, now here p is an integer, where p is equal to 3 an integer. Opening it by binomial theorem, an integer. So opening it by binomial theorem, we get, okay, we get here, this is sum of integration, actually for this is case number 1 when p is an integer. Case number 1 here. Now opening it whole cube. What is whole cube? 1 cube is 1 cube. But this cube is x raised to the power cube, means 3 here 9 upon 4. X raised to the power 9 upon 4 plus 3 into this. Okay, 3 into, let me write here, 3 into x raised to the power 3 upon 4 within bracket 1 plus x raised to the power 3 by 4. This is the whole cube of this question into dx. We have 3a into b, 3a into b into this whole value again. Then four steps will come out, 2 from this. So there are 3 power. In binomial theorem, one more step comes out to be the result in the result. In the result, we will have 4 steps, 1, 2, 3 and 4. Okay. This is how binomial theorem is opened. Let me take this as 1 plus x raised to the power 9 by 4. Plus the first will be 3 into x raised to the power 3 by 4 plus 3 into x raised to the power 3 by 4 plus 3 by 4 will be 6 by 4. If I add them, 6 by 4 is 3 by 2. It will be 3 by 2. So 6 upon 4, we cancel out by 2. 2 3 ja, 2 ja, 3 by 2. Why? Because when multiplication is there, bases are same, powers are added. 3 upon 4 plus 3 upon 4 is 6 upon 4. 4 are the same. 3 plus 3 6, 6 upon 4. 6 upon 4 is, we have to write in prime numbers. These are prime numbers, these are prime numbers, these are prime numbers. They are not divisible to each other, 3 by 4. But 6 upon 4 was divisible. We have to write it in prime number, prime factors. Okay, into dx. These are the 4 steps here. Finally, now we have to multiply by this and then integrate. So this step, let me multiply this. So it will be, first is x to the power 113 into dx into 1 plus sign of integration, this into this. Let me first write it as It is 1.3 plus 9.4. When bases are same, powers are added. Okay, into dx plus 3 into sum of integration x raised to power 1.3 plus 3/4 into dx plus 3 into sum of integration x raised to power 1.3 plus 3/2 into dx. Okay, now let us solve it further. This is integrated directly. It is x raised to power 1.3 plus 1 upon 1.3 plus 1 integration. And this is, let me first write it as unit. This is 4 plus 9 here 27, 9 here 27, 27 plus 4 is 31, 27 plus 4, 31, 31 upon 12 LCM. This is after taking LCM 3 into 4, 12, 4 into 4 and 3 under 27, 31 upon 12. Okay, plus 3 into sum of integration. It will be x raised to power 4 1 4, 3 3 are 9, 9 plus 4 13, 13 upon 12 dx. So 3 into sum of integration, 2 1 2, 3 3 are 9, 9 plus 2 11, x raised to power 11 upon 6. Because we have to take LCM 3 to the 6, 6 we have taken LCM and then that value is calculated. Now let me further solve it. So now this is already done. This is 4 upon 3. That is 3 upon 4. X raised to power 4 upon 3. Okay. Plus this will give us x raised to power 31 upon 12 plus 1 upon 31 upon 12 plus 1. After integration, so this is 3 into x raised to power 13 upon 12 plus 1 upon 13 upon 12 plus 1. Plus 3 into this x raised to power 11 upon 6 plus 1 upon 11 upon 6 plus 1 plus constant of integration. Okay, so now let me solve it further. 3 upon 4 into x raised to power 4 by 3 plus this is 30, 13 plus 12 is how much? 43. It is 43. So 3 plus, sorry, 2 plus 1, 3 and 3 plus 1, 4, 43. X raised to power is 43 upon 12, 12 upon 43. X raised to power 43 upon 12 plus this is 13 plus 12, 25 upon 12. So 3 into 12 upon 25. So 25 upon 12, 12 will come in the numerator. It is x raised to power 25 upon 12. Now plus this is 11 plus 6, 17, 17 upon 6. This will come here, it will be 18 upon 17 into x raised to power 17 upon 6. What I'm doing here? Yeah. Upon 6 only, because 6 3 is 18. 6 will come in the numerator here. So 6 into 3, 18, 18 upon 17. X raised to power. Now this let me write here 12 here 36. 36 upon 25. This is 36 upon 25. So 3 into 12, 36. 12 here 36 upon 25. This is the final answer plus constant of integration. Let me write here, this is the final answer. Question number 4th. This we have done. Okay, we have fixed this question. This is the solution of question number 4th. Now we see that how it is easier after okay, comparing this with the given function x raised to power n into a plus b x raised to power n whole power p. If p is integer, then this is the solution. This kind of solution comes out to be easier than. Okay, this is question number 4th. Let us talk about 5th question now. What is question number 5th? Let's talk about it. Now question number 5th. Let us talk about it. Now the question number 5th will give us. Let me take question number 5th now. Now question number 5th is of what height? Okay, now here it is p a prime number. I mean sorry, a fraction. Then what is the solution? Right? Check it further. This is x raised x only into 1 plus x cube whole power 1 upon 3. I'm sorry, this is upon 3 into dx. Now here p is a fraction. P is equal to 1 upon 3 of fraction. Okay, not an integer. So what we do, we check now whether n, this is 1 plus 1 upon n is 2 upon 3. N plus 1 upon 3 is not an integer. Okay, but if I add p plus n plus 1 upon n will give us here p is 1 upon 3 plus this m is 1 plus 1 upon 3. It is giving us 1 upon 3 plus 2 upon 3, 3 upon 3, 1 an integer. Okay, so this is part second of second case. Part second of second case is comes out to be an integer equal to 1, which is an integer we see. Now in this case, so putting x equal to 1 upon t will give us the solution. Now in this situation we always substitute. We substitute x to the power 1 upon t. Let us check. So solution. So x equal to 1 upon t. Therefore that is x equal to 1 upon t and dx equal to minus dt upon t square. Substituting these two values here in this equation, we will get minus sign. Now x is 1 upon t. This is 1 upon t. It will be t cube plus 1 upon t cube into 1 upon 3, and this is 1 upon 3. Okay, t cube plus 1 whole cube, but it will be 1 upon t cube. X is 1 upon x, 1 upon t. It will be 1 upon t cube. T cube take LCM, t cube plus 1, t cube plus 1 upon t cube power this. This is dt here. I'm sorry, into dt upon t square minus dt upon t square. Here we have to take this is t cube. This is also t cube. So what we have obtained here, let us check it now. This is 1 upon t, okay, and this is t only. This is t cube, so t4 we will have. It will have minus sign 1 plus t cube whole power 1 upon 3 divided by t cube by this is 1 t square 2 and 4 into dt. This is the value here. Now what we have to substitute? Now because this power is 1 upon 3, we have to substitute 1 plus t cube equal to u cube. For u cube only, then this power will be removed. Yeah, so it is 1 upon power. Question number 4, 3 cube. Okay, all cube. This is 1 upon 3. All right. So that we have to substitute. Now further substitution. So first we have substituted here x equal to 1 upon t. This is the first substitution. X equal to 1 upon t. Further substituting 1 plus t cube equal to u. Why? Because 1.3 power is whole. With this whole value in bracket, you can substitute like this. So in this case, t is 1.3. So this kind of situation is there. So now differentiating with respect to u, differentiating it with respect to u, we get finally we get here 3t square into dt, 3u square into du. 3 cancel out. 3 cancel out. So t square dt equal to u square du. T square, but is not there. If I multiply by t square, then t6 will come in the denominator. What will be t6 then? T6 then can be calculated as U cube. Okay, it will be written as, let me write it first as minus sine of integration. If I add t square in the numerator into 1 plus t cube whole power 1.3 dt divided by, this is t square here, t6 no change because 1 t square we have multiplied in numerator and denominator. It is t6 now, but power 2 is added here. T4 into t square, that will be the power 4 plus 2, 6. Okay. Now what does it give us? It will give us now minus sine t square dt is u square dt, and this is u only because u cube, u, let me write here, u cube whole power 1.3 into this is u square du. Why for t square dt, take this t square to this side, t square dt equal to u square du. Okay, in place of that, upon t6, what is t6 from this? This implies that t cube is equal to u cube minus 1, therefore t6 equal to u square minus 1 whole square. Because 1 2 power we have whole square go this side, so t6 equal to u square minus 1 or u cube, I'm sorry, it is u cube here minus 1 whole square, u cube minus 1 whole square is the value. Now what do we get here? You see u only, u cube that we have given here is minus sign u cube equals 1 u over 1, this physical log u, and this u square, that means u cube into du upon u cube minus 1, this is u cube minus 1, okay, whole square into du. I have already written. Okay, so further let me solve it here. It was u cube here, no problem. So let me write it here. What answer comes out to be? Let us check. So this is second substitution. Again, what do we get? Minus sign. If I add, subtract 1, it will be u cube minus 1 plus 1 will change upon u cube minus 1, it is whole square into du. So first will be minus sign u cube minus 1 upon u cube minus 1 whole square. Okay. So then this will give us into du the minus sign, and this minus sign, it will be minus sign du upon u cube minus 1 whole square. Okay, so this is this value. Now let me solve it further. So what do we get here? In the first situation, we have obtained, okay, this we have obtained as only minus sign 1 upon or du upon u cube minus 1. So minus sign is du upon u cube minus 1 whole square. Now these are the two functions. Okay, so this can be integrated by taking, this is by factorizing this, and this is also by factorizing, but whole square of this is there. This is by now partial fractions. We give a very lengthy answer, but let me solve them. Okay, so this is whole square of the two functions. Then by partial fraction we can do this. Okay, but it will give us in two different forms. Let me solve it then. And then finally we will substitute u cube equal to this 1 plus t cube. Let me write here u cube equal to 1 plus t cube, so that space can be saved. And we remove this. These are two substitutions just to solve it further. Now here this is u cube minus 1. Okay, now no substitution because u cannot be substituted here, because if I substitute something else, no fraction. Let me solve it then by that method. What is that? Du upon, this This is u minus 1 in one bracket, in other bracket u square plus u plus 1. This is whole cube of this aq minus bq. This is a minus 1 in one bracket, in other bracket it will be u square plus u plus 1. Okay, so this by past subtraction we can do this. Minus sign. Now this will be du upon, okay, a different kind of question has come up. No problem. Now this is what u cube. Again u minus 1 whole square, same value will be there, whole square of this, that the whole square of each. It is u square plus u plus 1 whole square. Okay, so now let me take this I1 and I2. I1, this is I2, both are negative, both are with negative sign. Let me now put them here one by one. Here I1 is equal to, this is the negative sign, but I am taking the positive sign here, du upon, then I will finally substitute. This is u square plus u plus 1. Okay, let 1 upon u minus 1, this is u minus 1 into u square plus u plus 1 is equal to a upon u minus 1 plus b u plus c on u square plus u plus 1. Okay, by past subtraction we have to do this. We have to divide it into two parts, but we are not able to do this with the help of another function. So for value of a, let me write here, 1 is equal to therefore u a into u square plus u plus 1, b into u minus 1 plus c into u minus 1 only, and this will be b into u square minus u plus c into u minus 1. Okay, plus a is the same value, u square plus u plus 1. This is the value of this equation number 1. Okay, so let me tell you this now. So what are the values of a, b and c constants? The question, so value of a can be directly calculated. Substituting u is equal to 1. So u equal to 1 is substitution of this question. Substituting, putting, let me take u is equal to, for value of a, putting u is equal to u minus 1 equal to 0 or u is equal to 1 in first, in the first equation. So what do we get? Value of u, 1 plus 1 plus 1, 3. So a is equal to 1.3. A is equal to 1.3. Now b and c, for that we have to equate the coefficient.